Okay, good morning everybody. We are on day 3. I hope the lessons have been going well so far. Joe Wicks is out there. Jump on Joe Wicks 9 o'clock every day. He is excellent. He's taking PE lessons for the children. It'll get your brain warmed up, get your body warmed up and get you ready for the day ahead. Remember, begin with your brain buzz. That's the mental mass. This will get your brain thinking. It'll also get you warmed up to some of the mathematical language that you're going to use in some of the lessons. So jump into brain buzz first of all. We are going to step into our numeracy work now. So squares, let's take a look at what we're doing. Okay, squares, let's take a look at what we're doing today. Today we're going to take a look at equivalent fractions, and we'll be using some mathematics to work out how to get equivalent fractions by dividing the numerators and the denominators. So there's our learning intention for today. If you want to pause the video, take that down. Okay, two shapes have been represented here. There are the whole shapes there and the whole shapes there. It has been divided into 12 pieces in our denominator here. The numerator is 10, so 10/12 is what you see here in the first diagram. The second diagram is a shape that has 5/6, so it's been cut into 6 and 5 of those are shaded in. But what you know is the two original shapes are the same size overall, okay? They're the same size overall. You could even say they are equivalent. Take a look then. Let's look away from the representation and have a look at the actual numbers. What do we notice when we go to the numbers? Look at the relationship between this number and this number. What has happened? You've got it. We have divided by 2. So this builds upon yesterday's work. So whatever we do to the bottom, we do to the top. We divide by 2. Now, that is the technique that you need to do. Look at the relationship. Try and figure out what have we done to get from here to here, and then do that same operation on the top to divide this by 2 to get this, and you'll end up with this number. Let's take a look at another example down here. So, question, what have I done to get from here to here? Hopefully you said, Mr. Hayes, we have divided that by 8. Okay, whatever we do to the bottom, we do to the top. So we're going to divide 24 by 8 gives you 3. Okay. This term and this practice is known as simplifying. Simplifying because you've made the fraction simple. You have reduced it down to its simplest form. You cannot go again and make that any simpler. So this is called simplifying. Okay, time to put this into practice now. Here we have two shape representations, okay? This is 6/9 and 2/3. So what I want you to do is to recreate what we have over here. Take a look at the shape. The denominator will be the bottom number. That is how many parts there are. The top number will be how many are shaded in. Dun dun dun! None of these parts are shaded in. You have got to work that out by looking at the relationship from here to here and think, how could I simplify that? What could I bring that down to make it simple? Okay, so this task is all about simplifying the fractions that you see there. Good luck. Okay, and a little bit of further practice then. This time, no visual representation whatsoever. You've just got to copy and complete the fractions in your books, okay? So take a look at the original fraction, look at the relationship. What did I do to get from there to there? Do the same to the top. And there's plenty of practice on this page for you to have a go at, and even some tricky ones towards the bottom, okay, in problem form. Good luck, squares. Okay, triangles, it's our turn now. So we are going to continue a little bit of work on fractions as well. Today we're going to be looking at equivalent fractions and extending that equivalence. This is all some serious language now. Extending that equivalence to include 9ths, 12ths and 20ths, okay? Let's take a look at our work. Okay, so there is your learning intention at the top, as I just said. Now I'm going to begin this lesson with a question. Can you name for me some fractions that are equivalent to 1/2? Take a minute, scribble some down in your book. What fractions can you name that are equivalent to 1/2? So think back to when we had fraction walls out. What does that look like? Which ones are the same? Off you go and do that. Okay, hopefully you come up with something like this. Well, you could have 2/4, you could have 5/10, you could have 3/6, you could have 4/8. all of the numerators are half of the denominators, which makes it the same as 1/2. Okay, so here we have some of those possible answers that you've got. I want to take a look at the relationship between the numerators and the denominators. Let's take a look at this first one, the half and the 2/4. Now we know that these are the same, we just talked about that, but what is the relationship between the half and the 2/4 in the numerator? What did we do to get from there to there? Hopefully you can see we multiplied by 2. What did we do to get from there to there? From our denominators, we multiplied by 2. Look at the relationship between this one and our next fraction. What is the relationship between 1 and 3? We multiplied by 3. The relationship between 2 and 6? We multiplied by 3 again. Let's go a bit further now. Let's look at the relationship between the half and the 4/8. What did we do to get from the half to 4/8? On the denominator, we multiplied by 4. What did we do to get from the half to the 4/8 with the numerator? You guessed it, we multiplied by 4. Can you see a pattern starting to emerge? Whatever you do to the bottom, you do to the top. So take a look at how your denominator changes in each one of these situations. Take a look at how your numerator changes in each one of these situations. There is a relationship always between equivalent fractions. You've just got to spot it. Finally, our last one, let's do the big jump all the way over to this side. What did we do to get from 2 to 10 in our half? We multiplied by 5. And finally, no prizes for knowing this one. It is times by 5 to go from the 1 to the 5. So hopefully you can see there's a relationship between denominators. Okay, there's a relationship between numerators. Whatever you did to the bottom, if you can do the same to the top, they are equivalent. That's the idea behind looking at the relationship between all of these numbers. Okay, so whatever you do to the bottom, you do to the top, and that works. You can see the relationship between a half and 2/4 and a half and 5/10. The same idea applies. Let's take a look at a couple of other ones then. Are these equivalent? What did I do to the bottom to get to the other side? I multiplied by 2. What did I do here? You got it. I multiplied by 2. This is equivalent. Over here, I multiplied by 2. I multiplied by 2. This is also equivalent. Over here, what did I do? Again, I multiplied by 2. And again, I multiplied by 2. This is also equivalent because the relationship between the numbers is the same. Time to put this into practice then. You can see we have equivalent fractions down here. What did I do from 6 to get the 12? I timesed it by 2. And you can see quite quickly that what I did from 1 to get the 2 was times by 2 as well. This is an equivalent fraction. In this exercise, I want you to visually represent that so you can see that these fractions are equivalent. Okay, so you're going to have a bit of practice visually representing the fractions, the equivalent fractions that are on show in this one. And in the links as well, you will receive a link that takes you to this page in the workbooks. This is the exact same. We're looking at different types of fractions that are all equivalent because they're visually represented here for you. And then over here, you can see the fractions have been written out, but there are parts missing. What did I do to get from here to here? Take a look at the original visual representation of it and fill in the missing links. Remember, there's always going to be a relationship between those numbers. Okay, circles, our turn. Now, yesterday we took a look at equivalent fractions, fractions that are the same, and been able to read that from a fraction wall. Now, today we're going to look at a couple of illustrations that will have different fractions, and you have to see if they are the same or if they are different and be able to write the fractions down on the page. Let's take a look at what we're doing. Okay, so take a look at the question up in the top left corner. Now you can see two visual representations of fraction. Okay, you have one of them that's divided into fifths, you have another one that's divided into tenths. Notice that the one with the bigger number on the bottom has smaller pieces, so the bigger number on the bottom means the smaller fraction. Right, so first thing you have to do, you've got one on the left that says 2/5. You will need to colour in 2 parts of the 5 parts of that whole shape. Then you will have to go over to the right hand side one. Out of the 10 parts of that shape, you need to colour in 6 parts. Now, the bit in the middle, the box in the middle, remember our crocodiles from yesterday, which one is bigger? Would be a crocodile facing the bigger one. Or if they're the same, what would you do? You would put the equal sign in. So today we're using a new symbol. We're using the equal sign, which means the same as. Okay, you'll use the same as. So we've also got, from our crocodiles, we've now got the same as symbol. And on the next one, you've got something that's divided into quarters. This is up on the top right. Divided into quarters, you will shade 3. You have another one that's divided into 8. You will shade 6. That's the top number. And then record your symbol. Crocodile or equal symbol. You have a think about it. On this second activity, what I want you to do is to colour in the circles to represent each fraction, and then put each fraction in order from smallest to largest underneath. So, look at the 5 diagrams that you have there. The first one says 3/4. 4, the bottom number, is how many parts that shape is divided into. 3 is the number of parts that you will need to colour in. Okay, and work your way across. You've got 2/8, 2/4. On the next row below, 5/8, 7/8. Then, here comes the tricky bit. Looking at those boxes underneath, it goes from smallest all the way across to largest. Take a look at your diagrams. Which one has the smallest amount shaded? What size is that fraction? Write it down into that box. Next, cross that one out, move on to the next one. Okay, now, I know that these worksheets are on the screen and you don't have them, but you could recreate these in your book. Instead of having a circle with 4 parts in your book, you could draw a rectangle that's made up of 4 parts. You could draw a rectangle that's made up of 8 parts for the second one and only shade in 2 of those. Okay, so you can do these activities in your books just by drawing out the shapes. Remember, the bottom number would be how many squares there are altogether, and the top number is how many squares you would need to shade in. The third and final activity is similar. Okay, it's similar. On the top line, these are like the squares in your book. You have 5 boxes and you would need to shade in 2 of them. Underneath that, you have 15 boxes, and you can definitely see that the bigger number 15 means smaller parts. So shade in 6 parts of the 15 and then see which fraction is smaller, bigger, or are they the same. Put your crocodile mouths facing the bigger one. Put your equal sign if those fractions that are shaded in are the same. Down at the bottom, they are shaded in for you. You've just got to write in what fraction is shaded and then how many parts there are in the whole shape. Good luck, circles. This is a good challenge for you today. Let's see how you get on. Okay, today's literacy work is going to be based on some of the research that you've been doing in your topic work over the last little while. What I would like you to do is to produce an acrostic poem using the letters that make up the word solar system. Now, here's an example of what an acrostic poem looks like. You can see that the letters are all on the left hand side, and the letter for solar system, S, would begin the first word of that poem. Okay, so we're going to create an acrostic poem using the words solar system, using the research that you've done over the last couple of days. Now, what should go into this piece of poetry? Think about it. Any good piece of poetry should paint a picture in your mind. Whenever you close your eyes and you hear your poetry being read back to you, it should paint a picture in your mind. It's all about descriptive language. Think about adjectives that you use. Get up the language ladder and use some powerful adjectives. Poetry might have rhyming words at the end. As you know, these are called rhyming couplets. The rhyming couplets could be on each line or every other line as well, but not all poetry has to rhyme. Here are some of the features that you might want to include in your poetry, okay? So if you've kept it to a rhyming pattern, you could give that one a tick. Did you use alliteration? Have you used similes? Some personification? An onomatopoeia? Definitely be using some powerful verbs and adjectives in there. There's lots of criteria in that checklist. You don't have to have it all, okay? You don't have to have it all. But do your best to squeeze in some to enhance your writing so that it's not just a basic description. We want to drift away into the galaxy or into our solar system. Good luck. Okay, and for our final activity today, what we're going to do is we're going to have a bit of a digital learning lesson today. With your iPad, with your laptop, with your Android device, what I would like you to do is to either install Google Earth or visit the website for Google Earth, and we are going to take ourselves on a tour around the world from space. So Google Earth will allow you to see what the Earth looks like from space, and I would like you to find out what the 7 wonders of the world are, and then visit each one of those on Google Earth. Now, be sure to check out your own house, check out your school, have a fly around the world, check out places you've been on holiday, but experiment with Google Earth and visit different places around the world. Hopefully you'll see just how vast the Earth is, and just how underpopulated it is in some parts, and just how well built up it is in other parts. I suggest you go have a look at New York, and maybe have a look at Paris and the Eiffel Tower as well. Have a look at those places and experiment with Google Earth. It's going to be great fun.